from the accuracy, recall, and precision. So actually, as Amma said, normally we use accuracy, right? But why we need, all of them? I think you should firstly think about it, right? Cancer people. Oh, good. So now I have two predictions from two models. The first models give me this prediction. The only two are incorrect is these two. They predict the non-cancer people into cancer as the one with cancer. So you can see it should be these two persons don't have cancer, but the model said they have cancer. The second models only predict one cancer people, say that is non-cancer people. So according to accuracy, which one would be better? Just tap the first one of the second one. Okay, so I think I need to, according to accuracy, which one is better? The second one, right? Because there exists only one wrong prediction, but here you have two predictions, two wrong predictions. But in practice, we may prefer the first model, right, rather than the second model. Anyone can tell me why we prefer the first model rather than the second model? Although accuracy said second one is better, but actually the first one is better in real world scenario. Why? You don't force positive. Oh yeah, you don't want to miss any chance in the medical fields. It depends. If it's COVID-19, if you miss one people, if it's COVID-19, there is a lack of doctors in the medical centers. So you can miss some COVID people because they won't die, right? They just go back home, then they may have fever, then few days later they will become healthy. But for cancer, yeah, in this case you don't want to miss any chance. False positive is worse. So let's say what's false positive? Okay, Maxwell. Maxwell mentioned false positive. Positive means the prediction of cancer people. Normally you have a target label. In this scenario, the target label is cancer people. Normally, target label will be encoded as 1. So here the target label is cancer people and 1. So the positive prediction is 1. So here, do you have false positive? Yes, you have 2 false positive. But here, you don't have false positive because the only incorrect prediction is negative label. It is predicted as negative label. So here is false negative. So what we want to say is this false negative is really the things we want to care, right? Because we don't want to make the healthy person, don't want to make the cancer people to be predicted as non-cancer people. Then these cancer people will feel good, then they go back home, then they think they don't have any issue, then they will die at home. So this is a true issue. So now go back to your comment. What you said false positive is worse. Actually, I think you want to say the false negative is worse rather than false positive in this scenario. But in some other scenarios, false positive is worse. For example, I will talk about false positive is worse. The scenario where the false positive is worse later. Actually, it's a scenario of COVID-19. The false model is preferred because cancer patient predicting negative is dangerous situation. Yeah, that's why the false negative is worse. So if you calculate the accuracy, you will see, okay, this one actually become better, right? Because the cancer people will go back home and they will die. So we don't want to prefer this one. So accuracy doesn't work. So let's see recall. Recall work. If according to this recall, this first one get better result, right? Even though it have two incorrect prediction, the second one has only one incorrect prediction. The recall tells us it will prefer the first one. Why? Because what recall care about is only the cancer people. Let me repeat. What recall care about is only the cancer people. To make it a general saying, the only what the recall care about is the target label. Here, the target label is cancer people is one, right? So now transform this language into the metric, okay? How to transform that? What it care about is target label, right? So what's the target label here? These four people correspond to the target label, right? So we only care about these four examples. So that's why the denominator is 4, right? So for these 4 people, how many examples are correctly predicted? In first model, 4. So that's why the first model get 100%, score. But for the second model, how many examples are correctly predicted? 1, incorrect. 2, 3. So it's only 3 over 4. So that's why it gets worse result. All good? So in conclusion, if you really care about the target label, you need to use the recall, okay? If you really care about the target label, you need to use recall. That's it. Any question for this thing? Oh, good. This is recall. Actually, you may forget it a few weeks later, but you can always go back to this notebook to recall your memory because it's really easy to forget. So normally that's one reason why in real world people always use accuracy, because that's more you won't forget what's accuracy, right? Accuracy is easy. If no question, I will go to the second scenario. I think the Maxwell says false positive is worse in some scenarios. That scenario is COVID-19. In COVID-19, there is a lack of doctors for diagnosis, right? And COVID-19 is not a big issue, especially normally everyone have the vaccine, right? So they just maybe feel some fever, maybe get cold, some symptom like getting cold. So it doesn't matter. So in this case, we don't want to waste a lot of medical results to this false positive people, right? False positive. Why? What's a false positive? Positive means the one predicted as target label, but it's not target label. In fact, it's not target label, but it is predicted as target label. This is called false positive. Intuitive enough, right? So in this case, let me let me make up some data. Here we have 12 people. We have 4 people. They are non-COVID people. We have 8 people. They are COVID people. Okay. So the first model predict the 2 non-COVID people as COVID. Non-COVID people as COVID. Okay. But remember, we have a lack of doctors, so it's maybe we only have 1 doctor. So he's very, very busy. Maybe if you make more workload for this doctor, he will get sick. If he gets sick, no doctor in this small town. Okay. So we really want to take friendly to this doctor. So this is first model predict. And for the second model, it predicts 3 COVID people into no COVID. It doesn't matter, he just go back to home and have a rest or good, right? So what we preferred is this model, right? So let's look at the accuracy and recall. For the accuracy, it prefers the first model, okay? For the recall, it also prefers the first model. It has a better score for the first model. Now we go to the precision. The precision, we have the second model has better result. Okay. So why it has better result? Now let me give an intuitive conclusion. The precision will always what the precision will care about is the positive examples. Remember what's positive example? Positive example is those examples, the model predicted them as a target label, right? Here, what's the target label? Target label is called COVID, right? So in the first model, what we care about? We care about this target label, COVID label, right? Remember, in recall, we also care about target label, but we care about the ground truth target label. But here we care about the predicted target label. So now here is a predicted target label in precision. How many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 positive example. So that's why we have 10 here. How many of them are correct? So these 8 are correct, right? So that's why we have 8 here. So for the second model, we have 1, 2, 3, 4, 5. We have 5 positive examples. How many of them are correct? All of them are correct. So that's why we have 5, 5. So we have 1. So we get better result. So now we can get into the conclusion. Precision is when you care about the predictions, you use precision. When you care about the ground truth, you use recall. Okay, that's it.